All right. An investor has his portfolio 20% in T-bills and 80% in stocks. The return on those investments is below. Let X be the return on T-bills. It has a mean of 5% with a standard deviation of 2.9%. And his return on stocks is Y with a mean of 13.2% and a standard deviation of 17.6%. So stocks make more money, but they're riskier. T-bills are pretty consistent, but you get a lower return, I should say. So if you want to find his expected return on his investments this year, well, we want to find the mean of 20% of X plus 80% of the Y. So that's looks like this. So first, let's find the mean of 0.2x. That's going to be 0.2 times 0.05, which is 0.01. His mean of 0.8y is going to be 0.8 times 0.132, and 0.8 times 0.132 is 0.1056. Now, so when I add both these up, that's going to be 0.1156. So on his investments, he's going to average about 11.5% using this situation. All right, now from this previous situation, what is the probability that the T-bills get a better return than the stocks? Now, if we look at this, stocks get a 13.2% return, and T-bills only get a 5% return, but they're more variable. So we want to find the probability that a T-bill gets a better return than stock. Now to do that, we have to find the probability that T minus S is greater than 0, because we need a number on this right-hand side, because we want to look at our z-scores, and we need a number there, so it's 0 minus the mean over the standard deviation. But we don't know the mean of T minus S, and we don't know the standard deviation of T minus S. Well, the mean is always easy. You take the mean of T-bills minus the mean of stocks. So let's say that's 0.05 minus, or I can do it right here, 0.05 minus 0.132, I believe. Yep. And that gives us a mean of negative 0.082. And our standard deviation, to get our standard deviation, we have to take the square root of the standard deviation of t squared plus the standard deviation of s squared. So those numbers are 2.9 and 17.6. Now the thing that's confusing to people is even though there's subtraction here, we add in here. It doesn't matter if it's subtraction or addition here. Right here, we always add in our formula. So we take 2.9 squared plus 17.6 squared, and I find the square root of that number, and I have 17.84, say. All right, so now I have my mean and standard deviation, so it's 0 minus a negative 0.082 divided by, oh, now these are in percentages, and I didn't have it in percentages. So what I should have done is 0.029 and 0.176. That's just going to move the decimals, I believe. To be 0.1784. All right. Now that makes more sense to me. So 0.1784, which is going to be the probability that my z-score is greater than 0 plus or minus the negative, same as addition. So 0.082 divided by 0.1784 is going to give us 0.4596. So to find the probability, we do a normal CDF from 0.4596 to a very large number, and that's 0.3229. So there's a 32.29% chance, roughly, that T-bills will get a better return than stocks. If I drew out the normal curve, I could say that the mean is negative 0.082 with a standard deviation of 0.1784. So when is this going to be greater than 0? 0 would be about there, so we'd color in to the right here. Alright. Now George and Tom are in a golf tournament. Tom's golfs with a distribution of 110. This is your mean standard deviation. And George golfs with a mean of 100 and a standard deviation of 8. What is the probability that Tom will score a lower number to beat George? So Tom will score a lower number than George. So Tom minus George has to be less than 0. Now that probability is going to be the probability my z is less than 0 minus the mean over the standard deviation. So let's find the mean and the standard deviation. The mean is going to be 110 minus 100, which is 10. And the standard deviation is going to be 10 squared plus 8 squared. And then we take the square root of that, which is 12.8. Alright, so it's going to be 0 minus 10 over 12.8, which is the probability my z-score is less than negative 10 over that answer, which is negative 0.7809. So I'm going to do a normal CDF from a negative big number all the way up to that to get 0.2174. Alright, and that's my answer, and if I drew this out, our mean is 10, and we want to find the probability that is less than 0. So our standard deviation is 12.8, so it's going to be this area here that gets filled in. Alright. Last problem. Oscar and Charles are playing blackjack at Grand Casino in Hinckley. Oscar usually makes money with a mean of 40 and a standard deviation of 30, and Charles makes money with a normal distribution with a mean of 20, standard deviation of 40. What's the probability that Oscar will make more money than Charles? So we're looking at the probability that Oscar makes more money than Charles. That's the probability that Oscar minus Charles is greater than 0. I should have some distinction, maybe Oscar, just so that 0 and the O don't look similar. Alright, and that's the probability my z-score is greater than 0 minus the mean over the standard deviation. So let's find the mean of Oscar minus Charlie and the standard deviation of Oscar minus Charlie to see how this works out. So it's going to be 40 minus 20, which is 20. The standard deviation is going to be 30 squared plus 40 squared, and then square root that. This is like a 3, 4, 5 triangle, so this should be 50. So it's 0 minus 20 over 50. So that's the probability my z-score is greater than negative 2/5. Well, I'll go to my calculator. Normal CDF from negative 2/5 to a very large number, which is 0.6554. And that's my answer. Now, if I draw out my normal distribution, we have a mean at 20, a standard deviation at 50, and I want to find the probability that's greater than 0. That would be about from there to the right. So I'll color that in. Alright, well hopefully that makes sense and you can do this homework. Good luck.